So 2.3, we are going to be finding zeros of quadratic functions. We are going to do it with factoring today. We are going to do it completing the square next week. We're going to be just doing it all sorts of methods that we're going to continue to use forever and ever from here on out. So it'll be fun, right? So it says factor the expression x squared plus 7x plus 12. Does anyone want to dive in and tell me how I factor that? No? Well, I would take A. What's A? A is 1. 1 times 12 is 12, so I need factors of 12 that add to 7. 4 and 3, 3 and 4. So it's going to be x and x, because that's the only way you get x squared, right? Yep. And then 3 and 4 are factors of 12, and they have to be, and they're both what? Plus. So did we factor the expression?
Yep. Yes.
Yes. Guess how we find zeros? We set them equal to what? 0. Have we done this before?
Yes, we have.
So I would subtract 3, and x would equal what?
Negative 3.
-3, and I would subtract 4, and x would equal?
Negative 4.
-4. I am going to encourage you to write them from smallest to biggest, because when we graph it, then I already have my x-intercepts. Does this open up or down?
Up.
Up. How do you know, Cadence?
Because A is positive.
A is positive. Could I find the vertex down here if I wanted to?
Good.
Yep, and the vertex has to be exactly in the middle of -3. Oh, I put that on -2. You guys didn't catch me.
So,
Oh, why wouldn't you say something?
did you do it biggest to smallest?
Smallest to biggest.
-4 is smaller than -3.
Yep.
Yes.
I kind of forgot.
Okay, so I would bet that the x-intercept is -3.5, yes? Not the x-intercept, the vertex, the h, yes? And I would find that I could do 3.5, so 3.5 would be, what, 6, 7 halves? So I'd have to put -7 halves squared plus 7 times -7 halves plus 12. Is this everything we've already been doing?
Wait, how did you get that? Putting it in for X.
I'm putting it in for x. Because the h is right in between the two x-intercepts, yes? Because this would be that.
How did you get the 7?
Because 7 over 2 is 6 is 3, yes? And 6 divided by 2 is 3, yes? So 7 divided by 2 would be 3.5. Okay, that's how I got 7 halves. And I really would rather square 7 halves than 35, wouldn't you? Okay, so I get 49 halves minus 49 fourths, don't I? I forgot to square my 2, didn't I? Darn it. 49 halves. I said 4 and I wrote 2 again.
Don't do that.
I know. Plus 12. Then I have to get what?
You put 2 again.
Common denominator. No, I 2's right there.
Oh, yeah.
Okay. So my common denominator is going to be what?
4.
4. So 49 minus 98
That is 49.
plus 48. That's 4 times 12? Yeah? Because 12 has to be over 4 also?
Yes. Is that a...
Yeah, so 4 times 12 is 48. Okay, so 49 minus 98 is 49, correct?
Yeah.
-49 and positive 48 is -1/4.
Yeah.
So if there's 1, the -1/4 is like right here, isn't it? I should have done a different color. So I have here, here, and like here. Can I sketch my graph now? Yep,
Wait, do we have to graph these too?
eventually. What I'm trying to show you is look at what we just did with everything we've already known how to do. Correct? You guys were doing the vertex before. In this case, the minimum. Yes? You were doing the minimum, and then you were graphing the y-intercept if you could find it, right? Or you'd have to pick another point. That was the second IXL, wasn't it? But now, if I have the vertex and I have the two x-intercepts, can I graph it also? And I found the vertex without using negative b over 2a, didn't I? Could I use negative b over 2a?
Yes.
Guess what I would have gotten?
Same thing.
Negative 7 halves. Because b is 7. So it would have been negative 7 over what? 2. So we are not going to have to graph every problem, but I'm trying to show you what this is doing and why we're doing it. Okay? So next one, 2x squared minus 5x minus 3. So 2 is still prime, so can I still put it in my here? 2x and x? Yes? So 2 times 3 is 6, and I want difference because it's negative, right? So I want the factors of 6 that have a difference of 5. 6 and 1, and it's going to be negative 6, positive 1. So I've got a 2. So remember, this multiplication and this multiplication give me 1 and 6, correct? So I have a 2. I need to get 6. What needs to go here then? 3. Is 3 a factor of 3? What's the other factor of 3? 1. And we need negative 6, so the 3 has to be negative and the 1 has to be positive. We're using those patterns to factor, correct? Okay, if you want to factor by grouping, you better learn how to do it really efficiently. Okay, so now I set these both equal to 0. So on this one, I would have to subtract 1 and then divide by 2. And over here, I just add 3, wouldn't I? So x would equal negative 1/2 and 3. And if I were going to sketch that graph quick, I have 3 and I have negative 1/2. And I could calculate halfway between there, but wouldn't that be easier just to do negative b over 2a?
Wait, how did you get a half?
Because I would subtract 1 and divide by 2, just solving the algebra equation. Because right here, set equal to 0. So in this case, I don't want to find the halfway between negative 1/2 and 3, do you?
No.
Those aren't whole numbers. So I would say h equals 5 over 4. So it'd be 4/5. And then I would have 5/5, thank you. And then I would have to plug 5/5 in there and I could get it 5/4. Woo! And I could get my nice parabola, couldn't I?
Yes.
Okay. Actually, I was pretty close pretty close.
So today we're not doing like the graphing on it.
You may, but this problem, I'm just doing it all because we can do it all. Okay, factor the expression. X squared minus 9. What's special about this one? Can anybody tell me? There's no b, and 9 is a perfect square, correct?
Yeah.
So there's no b, so that means I need factors of 9 that have a difference of 0. What are those? 3 and 3 and negative 3. So my factors are what? X minus 3 and x plus 3.
And the answer is the same.
Not the same,
Yeah, x equals negative 3 and 3.
but that's not the same.
Yes, it is. X equals positive and negative.
I was thinking the same as 3 and 3, not the same as my factors. Were saying the same as my factors? Okay. So, are you just going to be factoring like we've done a ton already? Yes. Okay. I want you to solve, guys, not just factor. If it says to factor, just do what we're doing right here. Okay? Because that's good practice for us.
The zeros?
Yeah. Okay, because that's the whole point of factoring or finding zeros. Okay, now what do I do?
Put your 2 in the air and your negative 7 on the bottom.
3 times 2. 6 in the air. And is 3 prime? Is 3 prime? So could I throw it in there already?
Yes.
So 3x and x. And yes, 3 times 2 is 6. And what's this positive tell me right here?
It's positive.
So it's going to add.
Yeah.
So the factors of 6 that add to 7.
3 and 2.
Negative 6 and negative 1. Okay, so I started with a 3, so remember this multiplication and this multiplication, right?
Sure.
So 3 times a third gives me 1. You guys want to go there?
No.
No. So 3 times what gives me 6?
Two.
Negative 2, because it's being negative. Is 2 the factor of 2? Yes. Is the other factor 1 like it needs to be? Yeah, and it needs to be negative also? Okay. So now what do I do with that?
You set it equal to 0.
Set it equal to 0.
X equals 1 and 2.
I'll go with 2.
X equals 1/3.
1/3. How'd you get a third, Cadence?
Because you have to add 1 and then divide it by 3.
I have to add 1 and then divide by 3. And here pretty quick, and I honestly would think you probably should be able to do that in your head by now. Yes? So, 1/3 and 2. Did I write them in order? Yes. Now this one I wrote plus or minus 3, but I would assume you would know negative 3 was left of positive 3, right? Questions? Concerns? Okay. Didn't ask for objections. Ha ha. Okay. The graph shows a function defined as y equals x squared plus 2x minus 8. How do the zeros of the function relate to the factors of the expression? Well, these zeros better be the what? We just did them, guys. The zeros better be the factors, right? So let's check it out. Factor it. Y equals x squared plus 2x minus 8. Do what we've just done. They just waited to now to tell you that factors were zeros. I just told you from the beginning. Kyson, are you factoring? Matt, you already have it factored?
Hmm?
Do you already have it factored?
Doesn't know how. Sure.
Matt, help me factor it. What do I do
don't
first?
want to.
What do I do first, Matt?
Why can't Tyson? I don't know.
Is 1 prime?
Sure.
Yes. So I can just do this. So A times C. So 1 times negative 8 is what?
4 negative 2.
Yes, so positive 4 and negative 2. So are both of those factors of 8?
Yes.
Yes, so negative 2 and positive 4. You can do it, so do it. Kyson, what does x equal? I'm waiting. And? No. Set them equal to what?
Huh? 0.
0. So solve this. What would x equal?
Negative 1. I mean 4.
Negative 4. And what would this equal?
Positive 2.
Positive 2. So how did the factors relate to the zeros of this function? They're the same. Okay, what did I tell you? That zeros, x-intercepts, and solutions are all the same thing. Okay, the only difference is how we write them. Only difference. So if I ask you for a 0, you say x equals a number, A. If I ask you for an x-intercept, what is the y at every single x-intercept? 0. So you would write it as a comma 0. Bladen?
Yes.
turn around. Put your hand in your lap. Thank you. And if you want a solution, you would have x equals a. So I know that IXL does not follow those rules, do they? 1 second. If I ever ask you for an x-intercept, it better be written as a point. Got me? Yes, Ainsley? Are you sure? Okay. So if I ask you to answer any of those three things, what are you going to do? Factor and set it equal to 0. No matter which one of those I ask you, you're going to set it equal to 0, factor, and then set your factors equal to 0, right? Because it has to be set equal to 0 before I can factor in the first place. But that's what you're going to do every single time. Carly, you're good?
Yeah.
Okay. Everybody else not good? I think you were the only ones to writing. Okay, so what's going to happen here? You're going to factor it. Is it set equal to 0?
Yeah.
Yes? So now we're going to factor it, and we're going to find the two x-intercepts. It looks like we're going to get 5 and 4, right? 4 and 5? So let's see if that's what we get. Kyson, you're going to help me with this one.
No, I'm not, Miss Wink.
Yes, you are.
I'm sick. Can I
I
go
liked
to
your
the office real quick?
TikTok.
Yeah,
Thanks.
me too.
Thanks. Melissa said she wasn't going to share it.
She sent it to our class group chat.
No, she said she wouldn't post it.
Oh, yeah, she just let you guys post it. Okay, Kyson, first thing, is it set equal to 0?
Yes.
Yes. Is 1 prime?
Yes.
Yes. So I can put it in here as x and x.
Yes.
So I take 1 times 20 and get what?
20.
20. And this is a positive, so I'm going to be adding, yes?
Yes.
And they're both going to be negative.
Yes.
So what are the factors of 20 that add to 9?
5 and 4.
5 and 4.
Think my quick thinking.
So you have negative 4 and negative
5.
5. That's it. You factored. Bladen, what am I going to do next?
You make them equal to 0.
You're going to set them both equal to 0.
Yeah.
And x is going to be equal to smallest to biggest.
4 and 5.
4 and 5. How did you get 4 and 5?
Because I flipped the side.
You added over.
Why didn't you just tell me that's how you factored?
I've told you for
You
months
have
that's
not.
how to factor.
Now I get it.
I
finally
feel like
get
I
it.
get it more now than I used to.
Okay, that's good.
I'm going to forget when we
I
start
don't
the
even know.
assignment.
100% too.
I
Okay,
hate to break it to you.
you were factoring a week ago when we factored in for like 4 days in a row. It's exactly the same as what we were doing.
I can
Those worksheets that had like 40 questions apiece on them, that's what we were doing.
Put your arm on instruction.
We'll just keep going here. Okay. Oh, I can't go back. It's fine. It's fine, Kyson.
Why can't you go back?
Well, I can watch.
Oh, wow.
Every time I go back, it deletes. Well, maybe. Maybe.
Price and compare, I have it.
There. Kyson, I could. Hurry up. I don't think I can always do that, but.
It's write down every single thing.
Do I?
Well, there's not that much to write down.
Price and
He's
write
going
down.
to copy the top.
Yeah, it'll copy it.
Okay. Shh. Stop.
Done.
Thank you. Okay.
Graph.
So we have some definition stuff. The zero product property states that if the product of real numbers factors is 0, then at least one of the factors must be 0, i.e. if a times b equals 0, then a equal either, that should be either. And I'm going to, oh, it didn't. Should be either a or b is 0 or both. And is that a duh statement, guys? If two numbers times each other equals 0, one of them has to be what? 0. That's one of those kind of like duh things that we forget about. To use the zero product property, rewrite the equation so that is equal to 0, then factor. So we have been doing this. It's the first question I ask you every time. I ask you, is it set to equal to 0? And your answer is yes, and we go. If it's not, then what do you have to do? Set it equal to 0. Have we been doing that already without me telling you? Yes. In order to factor, it has to be set equal to what? 0.
Do you want us to write this thing underneath the definition too?
Well, those are examples, so
Are we doing the examples?
yes. Why would we not do
I
examples?
know my homework now. I know how factor.
Okay.
Sing some more.
So x squared, are we all at examples
No.
yet? Okay, let me know when we're good. This seems really little. Is that really little?
Well, little.
No?
Little's a weird word.
Tyson, do you like doing this stuff?
You're a little.
Okay, whoever said no, are we good now? Are we at examples? What?
Maybe.
Okay,
Nah.
so x squared plus x equals 42. What's wrong with the problem?
42 is not equal to
It's not equal to 0, right? So how do I have to move 42, right? So I'm going to subtract it. So I have x squared plus x minus 42 equals 0. And then I factor. So 1 is a, so 1's prime. So x and x. Factors of 42 that have a difference of what?
7 and 6.
So positive 7 and negative 6. So those are just the factors of 42, right? So plus 7 and minus 6. So x is going to equal from littlest to biggest? Negative 7 and 6.
That's it.
That's it.
This is negative. Your homework. I'm ready.
I'm ready too.
What if there's another?
Carly says she's ready now, but
Okay, you guys do this one then on your own. Okay, 2x squared. Please stop, Bladen. I said helpful. 2x squared equals 9x plus 5. Let's see if you guys can do this one right on your own.
Oh god.
Trying to see something. Oh, we do have to do positive negative intervals.
Not today.
Yep, we do.
No. Don't got time.
You guys ready? Can I start?
Yeah.
I accidentally wrote 15 instead of 5, so.
That probably wouldn't work very nice. I don't think you could get the factors of 30 to have a difference of 9.
Yeah, I was confused.
Okay, how did it go?
Great.
Great? Good?
Perfect.
Questions? Now, we'll have, there's like the example that I have in here. These are just more factoring. Okay, I'm hitting this golf ball. It says, when does the golf ball hit the ground? Well, when does the golf ball hit the ground?
When it hits the ground.
When it hits the ground, but you hit it. Here's a graph, right? And we hit it, and it's going to go up, and it's going to go down. And where is it going to hit the ground? What's that called?
0.
A 0, an x-intercept. How do I find a 0 or an x-intercept?
0.
I factor.
Well,
Is it set equal to 0? Yes. Is there any common factors there? 16. Probably want to do negative 16, right? We don't want a negative leading coefficient, do we?
No.
No. So negative 16, we're going to factor that out. So that means we're going to divide each one of these by what? Negative 16. So negative 16 divided by negative 16 is x squared. And then minus 1x minus, how about 2? Okay, now is this 16 out here going to be a solution? No, because I'm going to set it equal to 0, and if there's no variable, can I make 0 equal 16 or negative 16? No. So it's not going to, I don't have to worry about it. If there was an x with it, then I'd have to worry about it. Okay? So what do I do with this stuff in here then? Factor it. So I have 1, so I get 1 and 1, right? And 1 times 2 is negative 2. Need the factors of 2 that have a difference of 1. Negative 2 and 1. So x equals negative 1 and 2. Now, I talked to you about this because we have said a quadratic function, the domain is all real numbers, yes? But then I've always said, unless you throw it into an application problem. Yes? Okay, so I'm hitting this golf ball, and x is the distance away from me. Can I have a negative distance away from me? No. So, what is it? X equals 2 feet? Feet? Aren't we feet? Oh, wind buzz. Okay, I'm sorry. This is seconds. I'm sorry, not feet. So, but again, can I have a negative second? No. So 2 seconds. So I'm going to hit this ball. So this is like tip-top golf. I go there, I hit a ball off, and it takes 2 seconds to hit the ground. Is that about right? Yep. Okay. So did it matter that I put it into an application problem? Except when I got my answers, do I have to think about what I get out? Yeah. And I didn't scribble it out. I just drew a line through it so I can still see that you have it. Okay? The last thing we're going to do is intervals of increasing and decreasing. Oh, that's just the same problem.
Yeah.
Okay. Oh, I'm sorry. Positive and negative. When I touched it. Positive and negative. So before I do this, disregard those problems real quick. I'm going to draw a graph. Here's a graph. Yes?
Draw this.
Okay, if you want to. So you understand what positive and negative means, because we've done this before. Pretty sure. Okay, so we have an x-intercept here and an x-intercept here. Yes? Everyone following?
Yes.
So positive means the graph is, guess what? Above. That would be up here and where? Up here? So this would be positive, and down here it would be what? Negative. So if I said this is negative 4, and this is 6, so it would be positive and negative. I just write it on my paper so I can go across my graph left to right, like this. Where am I coming from over here? Where is this at? Negative infinity. To where? Negative 4, it is positive. Remember doing this before?
Yes.
Okay, then what happens between negative 4 and 6?
Negative. Why wouldn't that be positive? Oh,
Because I'm looking at the graph,
Yeah.
not the x values, the graph. And then what happens to 6 to positive infinity?
Goes back to positive.
It goes back to positive. So the only difference now is before they gave you a graph and said figure it out. Now do you have to find these x-intercepts to figure out those points? Yes, that is the only difference now. Add an x-intercept is where these things change. So in order to find an x-intercept, what do I have to do? Set it equal to 0 and factor, and then set it equal to 0, which is solving. Okay, can I erase this now?
Yep.
Is everyone good if I erase that?
Yep.
Okay, this is the easy way to erase it. Frontwards,
No.
backwards. I just asked if I could erase it.
Just kidding.
Okay, identify positive, negative. So, and I'm going to show you how to do that real quick. So the first thing I have to do is set it equal to 0. Is it set equal to 0?
Yes.
Yes. So I have to do what?
Factor.
Factor.
-3 and 1.
Cadence says -3, +1. Do you guys agree?
Yep.
Set those factors equal to what? 0. So I get x equals -1 and 3. Now I'm going to show you how to do this. We're going to do it different because I don't have a graph anymore, do I?
No.
Okay, where did I start? Where's clear out to the left?
Infinity.
Negative infinity. So I'm going to write int, and I'm going to write negative infinity to what? What's my first x-intercept? -1. And I'm going to leave -1, and I'm going to be just fine till I get to where? 3. And I'm going to leave 3, and I'm going to go all the way to where? Positive infinity. So I have my intervals. Okay? I want to know when this is positive and when it is what? Negative. So guess what I do? I just plug a point in that interval in, and I figure out what the sign is. Did you hear me what I said? The sign. Did I say what the value was? Nope. I said what the sign. If it's positive, the graph is what? Positive. If it's negative, the graph is negative. So what is a number between negative infinity and -1? Okay, so I'm going to pick a value, and then I'm going to get a sign. So -2, you guys agree with -2? So this is x equals -2, because that's what a value is, right? And I'm going to plug that -2 into the factored form because it's easier. And all I want you to tell me is the signs. Got it? So when I plug -2 into x minus 3, do I get a positive or a negative answer? Negative. When I plug -2 into x minus 3, that would be -2 minus 3. Wouldn't that be a negative answer?
Yeah.
Okay. Now I'm going to plug -2 into x plus 1. It's a negative answer. So I now have a negative times a negative, which is a positive. So the graph is what here? Okay. So between -1 and 3. Give me a number. What? 0. You guys agree with 0?
Sure.
Okay. So x equals 0. So I'm plugging it into here again just because I don't have to do a lot of work, or I could do the top one. But I have 0 minus 3, positive or negative? Negative. I don't care what the answer is, I just care positive or negative. And when it comes to fractions, it's much easier that way because it's positive or negative. When I plug it into x plus 1, is it a positive or negative? Positive. So what is a negative times a positive? Negative. So the graph is what? Negative.
Wait, Miss Smith,
What?
how do you know which numbers you can pick?
I can pick anything between -1 and 3.
Oh, so on the first one you pick something from negative infinity to negative. Oh,
Yep. Okay? From 3 to positive infinity.
4.
4? How about 10,222?
No.
Yes.
Okay.
All I want, guys, is positive or negative. Yeah? Okay, so I plug in 4. So 4 minus 3, positive or negative?
Negative. 4 minus 2.
Okay, 4 plus 1.
Positive.
And a positive times a positive is a
Negative, obviously.
positive. So without doing any work, I know that my x-intercepts are at -1, yes? And at 3?
Mrs. Smith, you could have figured that out without.
I know, but you have to do this because in calculus, we're doing it right now with calculus. So this is something that keeps building every year. So this says this graph is positive, negative, and then what? Positive. We are not going to just do it with parabolas. Parabolas are pretty basic, yes? We are going to do this with graphs that have asymptotes and everything going on.
Like a crazy graph?
A crazy graph. Okay, so what is the first thing I do with the next one?
Then you go to 0, which it already is, and then you factor.
And then I factor it. So factors of 21 that have a difference of 4.
7.
7 and 3.
7 and 3, which one's positive?
Three.
The the 3, because it's a negative, so they have to subtract. And so it has to be negative 7 and positive 3 to get a negative 4.
I agree.
Because it's this times this, yes?
Yep.
So I set both of them equal to 0. So x equals what and what?
Negative 3 and 7.
And it will just help you. It will help you if you write them from left to right, because how have we been doing everything? From left to right, from left to right. Okay? So I always start where?
From the left.
From the left.
Infinity.
Negative infinity. Oh, I got an int. Negative infinity to
Negative 3.
negative 3. Negative 3 to 7. And 7 to positive infinity. Now, guys, with functions, you can have as many x-intercepts as the function allows. So you could have a graph when we start doing rational functions. You could have 4 or 5 x-intercepts. So your interval analysis would be, if I had 5 x-intercepts, I would have 6 intervals to look at to see what was going on. And this is what comes into play, because I know a parabola ends up, or down, down, yes? But when we start going a bunch, we could have it ends up and down, we know that, but there could be 4 or 5 changes in between. Okay, so we need an x value.
Negative 4.
Guys okay with negative 4? Okay, so x equals negative 4. X equals, how about 4? 1 positive, 1 negative. Is 4 in between negative 3 and 7?
Yes.
Okay,
Or we could do 0.
or you could do 0, but I don't do 0.
Why not?
Because you're already going to find the y-intercept eventually. Sometimes it's nice to do another number just to second check. Okay, and 10? You guys good with 10?
Yep.
Okay, then we're going to get our sign, yes? And when our sign is positive, that means the graph is positive. When our sign is negative, the graph is negative. We don't have to write the negative positive, do we? Okay. So, negative 4, and we're plugging this negative 4 into here. So, negative 4 minus, negative 4 plus 3. Negative. Times negative 4 minus 7. Negative. So, a negative times a negative is a positive. Okay, I always circle my final answer. Because we could have a lot of negatives if we had a fraction going on, right? Okay, so 4. 4 plus 3.
Positive.
4 minus 7. So, a positive times a negative is a negative. 10. 10 plus 3. 10 minus 7. And the whole thing is going to be positive. Again, you know this graph is positive, positive, yes? So you should know that it should go positive, negative, positive. This is not about figuring out what this graph looks like. This is about practicing these skills so we can do them further on. Are they hard to do? No. It's, again, about understanding that positive means the graph is where? Above the x-axis. Negative means it is below. So basically, did we do the same thing every single problem?
Yep.
First, set it equal to what? 0. Factor. Set the factors equal to 0. What? And solve for x. That is your entire life from here on out. Because like I said, calculus, we are doing exactly the same things right now. We did increasing and decreasing. Does positive and negative have to deal with increasing and decreasing? Yes. So, take the opportunity to build the skills as we build them, and as we go along, it will be much easier to do. Yes? Jaden?
Can we do the odds?
Say odds.
Online it says evens.
Does it say even? Are you sure you were looking at Thursdays or Fridays?
Oh, I might have been looking at
So
next week.
can we do odds on both 5 through 8 and 19?
No, you do 5 through 8,
And 17 through 20.
and then 17 through 29 odd. We're on Thursday's assignment. I think I changed it on the calendar. I know I didn't change it in classroom yet because I don't have time to change it everywhere.
Wait,
So-
just doing honor?
We're doing just
5 through 6 is 5 through 8, same thing.
5, 6, 7, 8,
Okay.
and then 17 through 29 is odd.
Okay.
And I will post